So Riemann sums are a way to approximate their area under a curve. And let's say we have this graph of x squared plus 1, and we want to find the area under the curve to the x-axis to the line from point 0 to 4. So from x equals 0 to 4. And what we can do is draw rectangles or just lines that are equally spaced apart. I drew them at 1, 2, 3, and 4. And we can do like what we can do is we can draw rectangles and then calculate the area of those rectangles and then add them all up together. So first let's draw our points at every point on the graph. And there's basically like two main ways to draw your rectangles. The first one is going from the left point. And what that means is like starting from the leftmost point and then going to the right, drawing three rectangles. So if we start from x equals 0 and draw our rectangles over like this, and then do the same at x equals 1, x equals 2, and x equals 3, then these rectangles, their area is going to be what, like our approximation of the area under the curve. And what you can also do is you can draw your rectangles from the right. So start from the right point and go to your left. So this, this, and this. And this, using this method, the area of the rectangles will also be your approximation of the area under the curve. And as you can see, neither of these methods are extremely accurate. If the function is increasing like this one, then going from the right or the right rectangle approximation method is going to be an overestimation. But if we have like a function that's decreasing and then draw our points, go for the right, is going to be an underestimate. And if the function is increasing like this one and we draw it from the left, then it's going to be an underestimate. But if the function is decreasing, then drawing from the left will be an overestimate. So again, if the function is increasing, then drawing from the left will be an underestimate and drawing from the right will be an overestimate. But if the function is decreasing, then drawing from the left will be an overestimate and drawing from the right will be an underestimate. And there's also kind of a third way to draw your rectangles. You can go from the midpoint between each x value. So what I mean by that is like for this rectangle, you would go x equals 0.5, here x equals 1.5, x equals 2.5, x equals 3.5, and then find the corresponding y value on the graph. So it's here, 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 and here. And then draw your rectangle going from the middle. So it'll be this, like this, and like this. And this is generally like a much better estimate than using the left method or going from the right, because you go from the middle, and when this approximation is an overestimate or underestimate, it actually depends on the concavity of the function. So when it's concave up like this, then let's draw our rectangles. Midpoint here, like this. Well, it's hard to tell, but it's going to be an underestimate because when it's concave up, the midpoint is going to lie below what the average y value is in this interval. So that's just how concavity works. So when it's concave up, it's going to be an underestimate, and when it's concave down, it's going to be an overestimate. Now let's talk about how to actually calculate the area of these rectangles. So for example, let's make rectangles going from the left. So left rectangle approximation method, and our area, the sum of our areas of the rectangles is going to be our approximation of the area below this curve from x equals 0 to x equals 4. And what you can notice is that we can just multiply the heights of each rectangle by the base. And we already have the base. The base is just 1 for each rectangle because that's the increment of each x. And to find the height, since we're going from the left, our height is just going to be the y value of our point on the left of the rectangle. So here it's going to be at x equals 0, which is just 1, and multiply that by the width, which is also 1. Here it's going to be 2, because 1 squared plus 1 is 2, times 1 plus, and 2 squared plus 1 is 5. And then this 3 squared plus 1 is 10. So we have 1 plus 2 plus 5 times 10. 3 plus 5 times 10, whatever, is going to be equal to 18 units squared. And that's our approximation of our area using rectangles going from the left. And now let's try rectangles going from the right. So, boom, here, here, and here. And since we're going from the right, the height of a rectangle is going to be the point on the graph, which is on the right side of the rectangle. So again, this rectangle, the first rectangle, is going to be, the height is going to be 1 squared plus 1, which is 2 times 1, plus 2 squared plus 1, 5 times 1, plus 10 times 1, 4 squared plus 1 equals 17 times 1. And this is going to be equal to 7 plus 10, 34 units squared. And as you can notice, obviously, both of these areas can't be accurate. The area is going to be somewhere in the middle of 18 and 34. And as you can see, as we just discussed before, this function is increasing. So the left rectangle approximation method is going to be an underestimate, and the right rectangle approximation method is going to be an overestimate. And for the midpoint rectangle approximation method, or the midpoint rule, it's the same process as the left and the right one. You just take the middle value between your points on the x-axis, so 0.5, 1.5, 2.5, and 3.5 in this case. You find their y values and you use that as the height instead of just using x equals 1, x equals 2. I won't be doing that because it should be pretty easy. You should be able to know how to do it from this. It's just the same. You multiply the width, which is 1 in this case, 1 times whatever height this point's at, and then whatever height this point's at, this point, and this point. And then you add them all up together, and you should get something in between 18 and 34 as your answer. And that answer will be more accurate than either of these two answers. And just to review, we've gone over 3 ways to calculate areas so far under a curve: the left rectangle approximation method and the right rectangle approximation method, and the midpoint rule, where you take your x value in the middle. But there's actually a 4th way to calculate it. It's not as accurate as the midpoint rule, but it's easier to implement. It's called the trapezoidal rule. And what you do is you just draw a line between each y value of your points. So you kind of create trapezoids instead of rectangles. And you just calculate the area of these trapezoids and then add them all up together, which is going to be more accurate than your left rectangle and your right rectangles, but not as much as your midpoint rule, unless your function's like very linear. So what you do is just use the formula for the area of a trapezoid: 1/2 base 1 plus base 2 times height. And instead of like using your base here, which is 1 every time, as your base 1 and base 2, that wouldn't work. You kind of need to visualize the trapezoid on its side so that you have 2 different bases. So your base 1 is going to be this part, and your base 2 is going to be this part, and your height is going to be your width. That makes sense. So let's just add up all these trapezoids together. So 1/2 base 1 is going to be 0 squared plus 1. So 1 plus 1 squared plus 1, 2, and just times 1, we don't have to write it, plus 1/2, 2 plus 5, time plus 1/2, 5 plus 10, plus 1/2, 10 plus 17. Yeah, and again, your base 1 is your left side, your base 2 is your right side. So when you add these all up together, you should get 52 over 2, which is 26 units squared. And that's the area of all your trapezoids. And let's think back to what we calculated as our left rectangle and right rectangle approximations. So our left rectangle was 18, and our right rectangle was 34. And as you can see, this one's kind of in the middle, and it's going to be more accurate than either of these, but not as accurate as your midpoint again. And you might notice that it's actually exactly in the middle of these two, which means that it's not just a coincidence for this one. The trapezoidal sum is going to be equal to your left and your right divided by 2. So let's label area left plus area using the right divided by 2 equals your sum of all the trapezoids. And this works because, well, let's just visualize each rectangle or trapezoid, and let's draw our approximation from the left side, which is going to be up to here exactly with the height when the triangle starts of the trapezoid, and your right rectangle, which is going to be at the top of the trapezoid. So as you can see, we can ignore all this bottom part because it's all equal, but if you just add this rectangle, and divide by 2, you get this triangle, because triangle is base times height divided by 2, which is just this square divided by 2. So yeah, the trapezoid is going to be equal to your left rectangle and your right rectangle approximation methods divided by 2. So you don't have to do this area calculation every single time. But yeah. Now let's do a practice problem. And if you think you can do this one, then pause the video and do it. And in this problem, it says use 4 intervals to estimate the total leakage after 8 hours. And if we look at the table, we're given the time in hours starting from 0 to 8, and the leakage in gallons per hour, and just of something, doesn't matter what, and for each of these hours. And 4 intervals means like 4 shapes of our sums, like 4 rectangles or trapezoids. And just by looking at this, since there's 8 hours, we can automatically just like know it's going to be our rectangle width or trapezoid width is going to be 2, because 8 divided by 4 is 2. And after 8 hours, which means that we're going to include all of these hours. So yeah, that's what our width is going to be. And for this one, I'm going to use the midpoint rule. Technically, the trapezoidal rule would be accurate for this one because, well, that's only what we're given. We're only given like linear approximations. We can only assume that it grows linearly from each of these to the next. But to make it accurate to a real life situation, I'm going to be using the midpoint rule. So we put our width at the front, like I discussed before, and then we find out what the value of our midpoint is. And it's already given to us, of course, in this table. So the midpoint of 0 and 2 is 1, and the y value, or whatever our value is for 1, 3, 5, and 7 are, we multiply them up together, or add them up together. 70, 136, 265, and 516. And you add them up together and multiply them by 2, and you should get 1,974 gallons. And if you're not sure why this works, why just taking the area under this graph works to find your answer, well, just think about it. If we have our gallons per hour and our hours, what we're doing is multiplying the gallons per hour by our hours to find the area under the curve. And when you multiply the gallons per hour by your hour, this cancels out and you just get your gallons, which is what the answer is asking for. So yeah, our approximation is 1,974 gallons, and we don't really know what the true answer is going to be, because we're just given some points on a table, not a graph. But yeah, this is our best approximation, really. Now, let's do another practice problem. If you think you know how to do this one, pause the video and try it. In this problem, we're given the graph of x squared minus 2x plus 2, and we're asked to approximate the area under the curve from x equals 1 to x equals 5, and to use 4 intervals, which means 4 shapes. And so we're asked to approximate the area from here to here, everything under the curve, and let's divide this into 4 intervals. And for this one, just as for an example, I'm just going to be using the trapezoidal rule. So I'm going to be finding the left sum first, and then the right sum, and then averaging those out to find our trapezoidal sum. So the left sum is going to be 1 times 1 squared minus 2x plus 2, which is 1, and then 2 squared minus 2x plus 2 is 2, 3 squared minus 2x plus 2 equals 5, 4 squared minus 2x plus 2 is equal to 8, or 10, and yeah, those are our 4 rectangles, and when we add them up, we get 3 plus 5 plus 10, which is 18 units squared, or whatever our area is going to be. And now let's do the right rectangle. Let's draw our rectangles from here. So it's going to be 2 plus 5 plus 10 plus 5 squared minus 2 times 5 plus 2, which is 17, which is 7 plus 10 plus 17, which is 34 units squared. And yeah, coincidentally, these are the same numbers as our first problem. And to find our trapezoidal sum, we add these together, 18 plus 34, and divide by 2, and we get 26, whatever our units are. So yeah, 26 units squared, or whatever the units are for your problem, is going to be the answer. So everything that I just explained in the video, and all the problems that I went through, should teach you everything you need to know about Riemann sums. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.